Today is Saturday, February 25th. It's about 7 o'clock in the evening. Moon still got a little crescent quality to it. And if you can see over there, Jupiter and Venus the much brighter, are getting very close to some kind of an alignment, probably within about 5 degrees of each other. Goal for tonight is to recap the imaging that I did last night, this time in black and white using IR optimization, and having spent a considerable amount of time tightening up the GoTo alignment of the scope, because it was very obscure last night, hard to tell if we were actually finding the galaxies we wanted to find, and that may be attributed to having left the scope in color mode as well as being misaligned. Right now, the scope has been tracking Zarak, constellation, I think it's an Eridanus. Anyway, for about 30 minutes, it has drifted about 5 or 6 arc minutes off to the right, which indicates there's probably some value that's wrong in terms of how quickly the scope is supposed to turn. Periodic error is what you might call it. I'm not going to play with that as long as everything is pretty tight this evening. So, we're going to recap the observations of the previous night. Sky dark will be upon us probably in the next 15 minutes, and we'll go from there after I synchronize to Zarak. Okay, here we are with NGC 1832 right in the center of the field. And look at those parameters. I'm only at a shutter of 3242 sensitivity. Such a better view in my estimation. And I haven't even pumped it up. These are basically the settings that you get with a 6-inch view of the galaxy. I believe it's the magnitude 11 galaxy. I am quite impressed, but we're going to push it up a little bit. Go to 128. Let's go to 64 first and watch as the screen regenerates. So now we're in the view of maybe, let's say, an 8-inch scope. I sat down and figured all this out earlier, but I'm going to just wing it for the time being. I'll leave captions if I'm off. At 64 flood, it's basically taken about 2/3 of a second for 6 passes, or about 4 seconds to generate that image. I'm very impressed. It's centered up nicely. Now let's go to 128 flood. Now 128 flood basically will give us the view of maybe a 10-inch telescope. Notice the star that's also dominating the center of the field is beginning to crowd out the galaxy though. At 128 flood, we're thinking 9 seconds to generate an image. 1.5 seconds times 6. And then finally, we're going to go to 128 flood, which is going to be our set point for the evening. 256. Let's go to 128 first, which ordinarily would be the view of, let's say, a 12 or 13-inch telescope. However, we're losing a magnitude and a half due to low sky position. Once again, the galaxy is just above the dark bar. Pretty much face-on galaxy with a not a dominating central core, but a central core that bleeds off into towards the extensions. I'm wondering if this is a face-on spiral. I do not recall, or whether it is an elliptical galaxy. And finally, we'll go to 256. And now the big issue with 256, or it gives you views maybe of a 20-inch telescope, but any disturbance of the floor, we start getting comet-like stars, and it starts to complicate the image quality. But we want to compare to last night, and I believe I was operating at a 256 shutter flood and 42 decibels on the auto gain control. Here we go. Whoops. Keep pressing the wrong button. And with that, I can begin to navigate. Returning. 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 Exiting. And saving. Okay, let's give it the 18 seconds it needs to regenerate itself. Okay, here's our view of 1832. It's described as a ring galaxy of magnitude 11. Stars are shaping up pretty well. Lots of other faint fuzzies in the image. I don't know what that bright light is. I may go turn off the porch light. It may actually be streaming a little bit into the field of view. Ordinarily, it wouldn't be much of an issue since we're not having to dark adapt. Okay, so what I'm going to do now, we're going to try to cover all the galaxies tonight, but I'm going to go a step through the NGC catalog and pick out stuff in, oh, there we go, satellite. Pick out stuff that I might not ordinarily have looked at as well. But that means we're going to have to step through this stuff quickly because the battery's only going to last about 25 minutes. And stepping through the NGC catalog, the next galaxy was NGC 1843. We made the leap from Lepus, the Hare, to Orion, the Hunter. This is a magnitude 13, 2.1 by 1.7 spiral, 116 million light years distant. I didn't capture it last night, but it's very definitely in the middle of the field of view. So all my efforts of the day have really paid off. Once again, we're not going to spend much time in each of these, but we are going to try to move swiftly through the NGC catalog of galaxies associated with the Hare and the Hunter. Another galaxy in Orion, 1875, magnitude 13.6, 1.5.05 arc minutes, spiral, so it's a little more obliquely presented, but this one is hugely distant, 402 million light years. That's a ways out, and I can see what I believe to be the galaxy right about there near the center of the screen. There may be others in the image too. I did a little research on galaxy clusters, but I didn't find many associated with Lepus and Orion. That doesn't mean that there aren't other galaxies that are background. It just means that these galaxies may not be part of a family or a group of galaxies in the way our Milky Way is with Andromeda, etc., and the local group. Okay, now we're on to a real beauty, NGC 1886, a galaxy in Lepus, magnitude 12.8, 3.1 by 0.4 arc minutes, spiral, class SBC, 75 million light years distant, and only very vaguely hinted at last night, but obvious on the screen tonight, near the center as well. So tracking is beautiful. Look at that beautiful edge-on spiral galaxy in Lepus. Just a wonder to be held. You can only reach that far and have large enough hands. Gorgeous. Boy, I'm really renewing my faith in this thing now. I'm going to have to try running in color mode on one of these later on to see if it is any difference in the presentation. Because last night, the images were quite deficient. It was very difficult to make out these galaxies. And here's a beautiful edge-on spiral that we only had to guess at the previous evening, and the moon is even more advanced. Still centered up quite nicely, so I felt no reason to go back to 1875. This is 1886, galaxy once again in Lepus, magnitude 12.8. This is more of a edge-on spiral, class BC, 3.1 by 0.4 arc minutes, 75 million light years distant. Pretty far south. I'm going to leave it up to you to see if you can see the galaxy. And me later on, I'm going to sweep it a few times. I think there's one. Yeah, I can see an edge-on galaxy right above the bar at the, I would say, the 10 o'clock position from the center of the screen. There we go. There's our view. I'm not feeling like I can see it well enough to describe it, but it is edge-on, fairly large. It's got a bright core, which is kind of barred and extended. The spec on it, once again, is magnitude, almost magnitude 13, so this is pretty deep to the south, so that's a fairly good view, if I am not mistaken, and that is not the galaxy, actually. So let me sweep a little bit more in case there's another candidate. That seems about the most obvious one on the screen right there.
Well, NGC 1889, companion galaxy in Lepus, magnitude 14, smaller, 6.4 arc minutes. It's an elliptical galaxy, 110 million light years distant. I believe they're roughly the same as, I don't quite remember the last parameters.
Let's see, we did not make a jump, and you can see this edge on right there. Now we got to pick out where that other galaxy might be located. It did not make any jump, but boy, this sure looks like there's a faint galaxy right there in that location.
Again, NGC 1889.
Magnitude 14. That is impressive because we're losing at least a magnitude, possibly a magnitude and a half due to low sky position down there with us. Boy, I really love that spiral. Not NGC 891, but it has got its own virtues.
NGC 1906, we're now into the 20th century of galaxies in Lepus, magnitude 14, a little less than 1 arc minute by half an arc minute, a spiral galaxy 132 million light years away.
And let's see if we can pick it out. I think I'm seeing it there, but you know, there's some lots of other faint fuzzies in the image. But I can definitely make out a galaxy right at that point right there, which is probably a galaxy. It's near the center of the screen. Tracking alignment is very good this evening. I haven't had to synchronize anything since I started about 10 minutes ago. Interesting, it's got that bright little pink prick of light associated with it. I want to point out that sometimes when you get supernova, it can look just like that, what we're seeing there. Supernova in a distant galaxy becomes an incredibly intense point of light. I'm not claiming that's a supernova, but that really does give the appearance of what you might expect to see if some star in some distant galaxy were to suddenly just burst forth and releasing all of its primeval atoms into the universe for star and planetary formation. There's our view. I'm pretty sure that's our galaxy too.
A second 20th century galaxy, NGC 1924. In Orion, magnitude 12.5, a little larger than 1 arc minute, 1.6 by 1.2. A large barred spiral with a ring around it, 112 million light years distant.
Let's see if we can make out that ring. I can certainly make out the galaxy. Right there. It does seem to have a glow around it, and there is a central point. It's fairly intense. It also has what appears to be either another line of sight galaxy or an H2 region associated with it. Wow, we weren't getting any of this last night. Didn't help that we never knew where on the screen things would pop up, mostly in the upper right-hand corner on the camera. But there we are. Wow. Yeah, the galaxy is gaining some even more contrast and presence as we sit here still videoing it. But let's move on.
Okay, what we have here is a baby boomer galaxy, NGC 1954, after World War II in terms of corresponding the 20th century date. Galaxy in Lepus, magnitude 11.8, very large, 4.2 by 2 arc minutes, 134 million light years distant. I would say this is probably a galaxy of a size comparable to our own. And
The view we get is still generating on the screen, and that bright white is not due because I turned off the porch light. But I believe the galaxy itself is right there in the center. Must be getting some incident light going into the dew from a street light that's basically in the 10 o'clock position from where the telescope is located in the observatory. No doubt that's our galaxy, the core of our galaxy right there. But due to the extraneous luminosity, we're not getting a chance to see how really large it is. But certainly a better view than I've had the previous evening.
we leap a few years into the future to 1957, a galaxy in Lepus, magnitude 14.8. There was hardly any adjustment in the position, so this is a very close neighboring galaxy. 1 by 0.8 arc minutes. It's an elliptical galaxy, 147 million light years distant. Not sure if that corresponds to the previous one, but
here's the image on the screen. Once again, we are being bollocksed up by the local street light, and I'm going to have to sweep to try to get a high contrast location. Concerns me that there's all those little faint fuzzy spots all over the screen, but that one right in the middle there, that could be the previous galaxy, and oh, there was one there with that star, wasn't it? That may be the one. So it's possible that I got a, I don't know, I didn't notice that one before. Anyway, there's some confusion about this next galaxy, 1957, but it's somewhere there on the screen and in the very middle. So hopefully this image will solidify and we'll get a more pointillistic view of the stars and get rid of some of these fuzzies that are all over the screen that complicate the process of identifying galaxies. Anyway, have a shot at it. Not disappointed, we've seen some great views, especially that edge-on galaxy we saw earlier in the evening.
okay, here we have another galaxy, 1964. Galaxy in Lepus, magnitude 10.8, but very large, so it's going to have low contrast, low 5.5 by 2.1 arc minutes. It's a spiral galaxy, 71 million light years distant.
Fortunately, the screen looks pretty good, and I can see where the galaxy is located, just above, probably, well, I don't know, magnitude 10.8 could actually be that very bright object, right, the study right there. That could be the core of it, because I'm seeing extensions going out to the side. The galaxy is classed as a spiral, and it is twice as wide as long as it is wide. Yeah, that's probably our baby right there, and it looks like it has a neighboring galaxy as well at its 8 o'clock position, very nearby. Yep, that's our galaxy. What a brilliant core on that thing. Wow. And you see, 1964.
Here's another galaxy in Lepus, 1979. We're progressing up to our current era. A galaxy, magnitude 11.8, 2.2 by 1.8, spiral galaxy, 68 million light years distant.
And yeah, wow, I don't know. I wonder if that's, we did move a bit of a ways. Yeah, there's definitely a galaxy there. Right a little bit to the left of the very center of the screen. It's got a brightish core and wispy extensions. It looks like it has about the right aspect ratio. There we have it, NGC 1979.
Still leaping around the hair, Lepus, NGC 1993, magnitude 12.4, pretty much face on, 1.5 by 1.54 arc minutes, spiral, 135 million light years distant.
You can see it just a bit above the center of the screen on dark blue. I don't know, maybe that bright spot, it seems to be accompanying a number of things that I'm going to have to pay attention to it. It could be a pixelated region of the imaging module or the screen. Pay attention to that as I move around to our next study, but it's interesting that it happens to be right where the galaxy is located here in the center. Okay, that be NGC 1993.
Another galaxy in Lepus. Who knows that the Hare harbored so many deep sky wonders? NGC 2073, magnitude 12.4. Pretty face-on, 1.4 by 1.5 arc minutes. 135 million light years distant. 21 degrees below
celestial equator. It's taking a while to take form. See the galaxy right in the middle of the screen, however. There is that bright pixelated point. I think that's probably an artifact. So, however, that is pretty much how a nova would look if it were associated with the galaxy. Yep. Looking pretty good there. It's too bad we're getting such incident light, but the telescope is tilted towards the ground and there are local street lights. Well, that's our view of NGC 2073, 50 years from now.
NGC 2076, galaxy in Lepus. Once again, magnitude 13, 2.2 by 1.3, kind of an oblique presented spiral galaxy. Some 99 million light years distant.
And here's our view, and interestingly enough, it's associated with that little bright artifact on the screen again. Boy, that supernova must really be getting around. There's our view. 13th magnitude galaxy. Sure is nice having an accurate GoTo track and GoTo find. And also, really, it does indicate to me that don't use color mode when you're doing galactics real-time imaging with the Rev2 system, although I have yet to test that out.
Once again in Lepus, NGC 2089, galaxy, magnitude 11.9, a little more oblique at 1.9 by 1.2 arc minutes, spiral. Looks like 131 million light years distant.
Lots of brightest stars here. I wonder if there's a cluster here as well, but the galaxy's pretty obvious right there. You can see some of the extension. Stars have the brighter frontiers, even though they are a little messed up at this angle. And the galaxies tend to blend off. Discount anything that looks like a really faint kind of a blotch. Who knows what that is? Atmospheric water vapor, who knows? But that's our view of NGC 2089.
Lepus certainly seems to be a galactic wanderland, doesn't it? NGC 2106, magnitude 12.1, another oblique galaxy, 2.7 by 1.4 arc minutes. It's a B spiral, some 83 million light years distant.
And once again, centers nicely, almost the exact center of the field. Very pleased. Even from my angle, I can see some fading on the frontiers of the galaxy, indicating the spiral arms. Not bad. NGC 2106.
Made the leap to Orion this time. Mostly in Orion I've been seeing lots of clusters with nebulosity, new star forming regions in the Orion minor spiral arm of the galaxy. NGC 2110, magnitude 14, fairly large, so it's going to be low surface brightness, 1.7 by 1.2. That would pretty much give it a average surface brightness of about magnitude 15, 101 million light years distant.
And there she be. Oh man, we did not find these that well last night. That is brilliant. Magnitude 14 galaxy. And an area of the sky where you lose at least a magnitude of reach. Very impressive as you can turn these things up with a 6-inch scope. Really does recommend using some kind of an imaging system on your scope for deep sky. Especially where you have lots of incident light that screws around with your dark adaptation for optical astronomy. And when you want to share the view with others. Yeah, there's that little pixelated point artifact right near there. So yeah, that's been pretty persistent now.
This is a 4-star alignment after flipping the scope back and forth between the eastern and western parts of the sky using the moon and planets Jupiter and Saturn, making various adjustments, including a slight tilt to the azimuth. It was off to the north a little bit. And a 4-star alignment is giving parameters that are all pretty close, less than 2,000, which in my estimation is a good place to start, especially if I get the same kind of values to the west as I am now getting to the east. Okay, and here, after exhaustive mechanical work aligning everything up on the azimuth and the declination, are the values for 4-star alignment to the west, also all below 2,000. So I suspect these values look pretty good. I believe they're in arc seconds, which is considerable number of arc minutes at 60 arc seconds. But they could also be an encoder count, so I can't be sure about it. But I'm going to go ahead and make a swing on the moon. Now remember, anything planetary is in motion, and it's calculated mathematically based on orbital data. There's no guarantees. You never do a star alignment or a mount alignment to planets and the moon for that reason, because they're only approximations of locations. But the moon centers up pretty good. I'll have that for future reference. Okay, I've just flipped the scope over to the west, and this is a view of the moon in the field of view. It's slightly off, probably about 10 or 15 arc minutes from missing the center along the north-south axis. Now I'm going to do an alignment with Zorak, which I just did as my 4th star, and to the east.
Yeah.